So the people who are gonna, replace me, they're gonna do the live lectures starting from Wednesday. So there'll be no interruptions during your instructions. And I will be meeting them before I leave. And I will tell them, what I have done. And I will leave everything, afterwards to them. But I will let them know what has been covered and what is my plan and so on and so forth. And they will be in charge of your study and learning for the remainder of the semester, including, assigning you a grades. So whatever grades you earn, and they will assign you grades for that course. For the amount of for the time I will be, before I leave, right? There are a couple of things I like to cover. And today I like to cover, I'm going to just cover as much as I can, especially those that are, I think is, may not have been covered thoroughly by some of the textbooks. Okay, so one of the things that you are going to learn to deal with is that, for example, I emphasized quite a lot on this function, right? I keep telling you this could easily earn you 10, 20 points, 20 points, right? So the absolute value of x equals to the these two cases. There are two cases. Right. Okay. So we have the narrative. We have the narrative, right? So if, okay, the question I'm referring to is in your notes is basic 51A. Okay. These are about piecewise functions. Okay, piecewise functions. Piecewise function is some kind of function you're gonna encounter at the beginning of the semester in calculus classes, in the calculus 1. Okay, and this absolute value function in particular is very much covered, and there's a lot of variations of it. There are lots of variations of it, right? Some of these variations, I've taken some exercise from the calculus textbook, and from those examples, I want to show you how we break them down into piecewise functions. Okay, so the title is called Rewrite Functions as Piecewise Functions. What is a piecewise function? Okay, for example, the absolute value of x, we have two cases. Okay, if x is greater than or equal to 0, right, the absolute value of a non-negative number is the same as the number. If x is negative, the absolute value of a negative number is its opposite, right? Remember that narrative, right? So this is the narrative. But this narrative can be extended to other cases. For example, on basic 51A, okay, the first, I give you like 8 exercises and eight exercises, and there's also more exercises on 51B. And most of those questions are from the calculus textbook. Most of those questions are from the calculus textbook at different stages of the calculus course, and they're used for different things. But just in terms of the function themselves, right? The way we handle it, the way calculus handle these functions is typically break them into pieces. How many pieces? In most of the cases, just 2 pieces, right? Just like this function, you have 2 pieces, piece 1 and piece 2, and they're separate. They'll be handled separately. So at the entry of your calculus classes, you will start to do this, and they're not usually show up as absolute value of x. they could be showing up as the absolute value of x plus 2, for example, right? So if it's the absolute value of x plus 2, how do you break it to pieces? Okay, and I'm going to show you how. Okay, and for example, in this case, right, I will treat x plus 2 as omega, as just one entity, So if I treat this as omega, so this I can view this as omega. So I want to give you guys the perspective, right? And I also want you guys to see the simplicity. So these will be so you basically x turn into bologna. X turn into bologna. Does that make sense to you guys? Yes?
Mm-hmm.
Okay. So then I'll just copy the whole thing. But when omega is replaced by x plus 2, hold on. When omega is replaced by x plus 2, all the omegas turn into x plus 2. So you treat x plus 2 as one single number. Do you guys see that? Okay. And the next step would be that you don't need to do much on the first part, right? You just have to solve these inequalities. And you can, well, x plus 2 is greater than or equal to 0, that means x is greater than or equals to -2. And from x plus 2 less than 0, that will turn into x is less than -2. So one function turned into a piecewise function. There are two pieces. Okay, there are two pieces. So what are these two pieces? As we know, the v-shape, right? The v-shape function. When this was x, right? It doesn't matter. If I just graph the absolute value of omega, how would it look like? How would it look like? It's a v-shape. It's a v-shape, right? There are two pieces. So that's why it's called a piecewise function, pieces. So in the examples I prepared for you, there are cases they have 3 pieces, and you can certainly imagine there are 5 pieces and 10 pieces and so on and so forth. But most of the cases, you're not going to be dealing with 10 pieces. You're probably dealing maximum of 3 pieces. Okay. So in these cases, right? So absolute value of x is seen as 2 pieces, right? And that's why it's called piecewise function. And one piece is the omega, right? This is one piece. So this piece is omega, and the other piece is the other one. So these two functions make the 2 pieces, right? There's one piece, one function. The 2 pieces is called piecewise function. Okay, and this function has wide applications, has a variety of applications. Okay, and these are one of them. So you're gonna use these like typically in the continuity, limits, the continuity, differentiability, and integration, these are all calculus concepts. Okay, so let's try one more, and then I'll give you a chance to try it. Okay, so you can see you really just, when in the process you work it, right? You treat this as one number. Okay, so in my mind, when I go through this, is that if x plus 2 is greater than or equal to 0, the absolute value of a non-negative number is the same as the number. The absolute value of a negative number is its opposite. So this narrative, okay, if you understand it, it will help you tremendously. Okay, that's why I have emphasized so many times. I even have seen them on quizzes and exams, right? Yes. Okay. Another one we can work with is number 3. Number three. Number three, we have a function called h of x, right? And this function is the absolute value of x divided by x. How do we deal with this function? Right? How do we turn into pieces? Because we do need to turn into pieces when we're handling calculus concept, okay? Limit from left, limit from right, and so on and so forth. And we will still be using the same narrative. The absolute value of a non-negative number is the same as the number, which is the branch on the top. And the absolute value of a negative number is its opposite, is its opposite. And then with that said and done, we're gonna get the absolute value of x divided by x, right? So this piece, when we divide it by x, okay? And the other side will also be dividing by x. Okay, so let's make it 175%. So you can see the negative sign. All right. And then you just simplify. And then you just simplify. Right here. X divided by x is 1. Negative x divided by x is a -1. And you're done. Okay, then you're done. And two more examples and we'll move on to something else. Okay, we'll move on to something else. Okay, I will give you homework on this part, but this week I don't think I will be giving you quizzes. I think I'll be turning into the other professors and they cover it. But for you, the materials I cover today and tomorrow will be very, very important for you to understand and know how to do for your calculus classes. Okay, so the next one I will be working on number 7. I'll just show you. Okay, the g of x, right? G of x equals to the absolute value of x plus 2 divided by x plus 2. This is very similar to number 3. Okay, so we just did, right? We just did x plus 2, absolute value of x plus 2, didn't we? So we just did that. And we take what we got there. We take what we got there, right? And then we're gonna do, and we're gonna work the g. G is defined as absolute value of x plus 2 divided by x plus 2. And, oh, by the way, I forgot something. Okay, here, there's a domain issue here. There's a domain issue here because we're dividing by x. We're dividing by x. Because we're dividing by x, x cannot be in the domain. So here it should be positive. Okay, it should be positive, not equal to 0. You guys follow me? I almost forgot. You guys see that? Because the domain requirement. Okay, domain is x cannot be 0. X cannot be 0. And in the next question, okay, we also need to be aware of the domain. Domain is that x cannot be -2. All right, x cannot be -2. So with that consideration, we can set this up correctly, but when we divide by x plus 2, okay, domain is x cannot be equals to -2. So this has to be greater than -2 and less than -2. Divided by x plus 2, divided by x plus 2. Okay, so that's because of domain requirement when we divide by x plus 2. So you can see the handling of these situations is pretty straightforward if you know how, especially if you understand that narrative. I emphasize that the absolute value of a non-negative number is the same as the number. The absolute value of a negative number is its opposite, right? The more you use it, right, in this case, or in the case that we talked about before, the more you use it, you realize how powerful these two narratives are. And it's going to carry you, through a lot of questions that you will encounter in your calculus classes. Okay, so this is number 7. The last I will cover would be number 6. You say, why did I cover number 6 after number 7? Well, that's because number 7 is closer to what we covered for the absolute value of x plus 2. But it really doesn't matter here because you just want to be able to handle these situations. All of these questions are selected from your calculus textbooks. Okay, I did not create them, and I'm just being a copycat. Okay, so here you got x squared plus x minus 6 divided by absolute value of x minus 2. The absolute value of x minus 2. So from the domain perspective, so here I'm going to invite your participation, okay? Of course, the denominator cannot be 0, therefore x cannot be equals to 2. So domain is set, okay? And next, okay, your turn. I want you guys to, your try, okay? I want you guys to try to break x minus 2 into 2 pieces. Could you try to do that? Can you break this into 2 pieces for x minus 2, similar to that of x plus 2? Could you do that? Is Farouz there?
Yes, Professor.
Okay. How's everybody doing? Can you turn that into 2 pieces? Similar to what we did with absolute value of x plus 2. You think of x minus 2 as one entity. That's your omega. That's your omega. Okay, we need to learn to think of that. We need to learn to think of it that way. You don't have to physically replace x minus 2 by something. You can just think of it as something. It's just one entity. It's one number. X minus 2 as one number.
For the top, it would be x minus 2, and then it would say if x is greater than or equal to 2 for the side.
Very good. If x is greater than or equals to 2. And the second row?
It would be negative parentheses x minus 2 and parentheses, and then if x was less than or equal to positive 2.
That's it. X less than 2, right? You can see as you get used to the narrative, it's just come to you, right? And then how do we handle the rest? How do we handle the rest, right? we need to be aware of the domain issues. So the x minus 2 cannot, when x minus 2 absolute value in the denominator, x equals 2 cannot be in the domain. So the one you use is actually if x is greater than 2. So when we're handling this situation, right? So we will have these two pieces. We have two pieces. Okay, we'll have two pieces. One piece is for x is larger than 2. X larger than 2, there's a little details you need to see that this is greater than or equal to. For here, greater than or equal to is fine. But here has to be larger than 2 because we need to guarantee the denominator is not 0. And next, in this case, when we are dividing x squared minus x squared plus x minus 6, and this in this case, x greater than 2, we'll have x minus 2. So the absolute value sign is gone. In the second case, if x is less than 2, then we will have the x squared plus x minus 6 divided by negative of x minus 2. And then you simplify. Then we simplify. If we simplify, what do we get? In this case, we can factor the numerator. We can factor the numerator. The numerator can be factored into x plus 3 times x minus 2. Okay, so for both cases, the top can be factored. And in the end, because one of the factors is the same as the denominator, so reduction will take place. Okay, reduction will take place. So when we reduce x minus 2 with x minus 2, the top will be x plus 3. The bottom, x minus 2 divided by x minus 2, it will be, so the bottom will be just negative of x plus 3. Okay, so this is how you handle these pieces of functions. And moving forward, you guys can practice with 51b and so on and so forth. Okay. Make sure you get those. Make sure you get those. Okay, you will need them in calculus classes. As far as piecewise function goes, and I think you already understand the piecewise functions. And the questions I put on basic 50A and 50B, and those are most of those questions, I would say 99% of those questions, they're exactly from your calculus textbook. The pieces may not look the same. The pieces maybe, this piece is sine, that piece is cosine, but the same idea. So I'm not going to cover in this class now. I just touch base with it. Okay, I just touched this and that because I found this one might be little bit difficult for you guys from my my experience teaching calculus classes. The next one I wish to cover with you is called decomposition. Right? Some of you asked me a lot of questions about composing functions, but the next topics I'm going to talk about is called decomposition of functions. Okay, where do you find these topics? These topics can be found, unfortunately, there are not a lot of textbooks that address these issues. I found that students have tremendous difficulties when they were in chain rule. Okay, so for that reason, I constructed these exercises, and most of these exercises are from calculus textbook. Okay, they just didn't have that decomposition step. So the exercise, you can find it at basic 43A. I don't know what page. Okay, go find it. It might be 70 plus 22. Okay, I think around that neighborhood. So, page number 92, something like that. Did you guys find it? Because if you want to do more exercise, that's where you find them. Decomposition. Okay, I call them, we talk about the compositional function, right? We talk about compositional function. What is a compositional function? F composite G, right? Is f of G of X, okay? And you could have many layers. Okay, I remember the other day, and one of you asking these questions during office time. I posted those in the, I posted the recording in the, in last week. I think it was last week, right, Jacob?
I believe so.
We did it last week. So we understand the composing function, right? Composite function. We talk about these things at the beginning of, throughout the weeks, right? And we have a composed sign, arc sign, E, ln E, ln X. We have done some composition. But what you need in calculus class, when you're in chapter 3, when you learn chain rule, is you need to decompose. Okay, you need to decompose. In other words, you know the function, and you're going to go back to see what would be the original function to make the composites. Okay, these kind of exercises are as far as I see, there are not as many such exercises. So I put these exercises together, and the questions I have selected are mostly from calculus textbook. Okay, so as you enter calculus class, you almost immediately need this skill. And don't be scared. It's actually pretty, it's not that hard. It's not that hard. If you understand composition, you understand decomposition, then you will understand why I show you the composition at the beginning, right? From time to time in the past weeks. So let's look at the composition. Okay, did you guys find that page? Did you guys find that? It should be titled Basic 43A.
I think it's
something like
page
that.
105.
Page 105?
I think,
I'm sorry,
yeah.
I said 92. Because I'm using the older version of it. Did you guys find it? Page 95. Page 95. These basic skills, you will need them because chain rule, derivative, applying derivative rules, the chain rule is one of the harder topics for students. One of the hard topics for students. But if you understand decomposition, for you, it will be a piece of cake, I hope. All right. Say, for example, the first one. Okay, the first one. Cubic root of 1 plus 4x. Okay. At the time I was writing that exercise, I did not use the word decomposition, but I think now I can introduce a word called decomposition. Decomposition. Okay. So at the time I was writing that. Is that written down on your version? I don't think so. I didn't coin the word then, because these words were not officially or formally coined as well. As far as I know, I haven't seen them in any textbook be written that way. And there are very few exercises about to address this issue. Okay, so here you go. How do we decompose? I would say maybe because it's too easy. Okay, but that's not what I saw when I was teaching Cal. So here you go. So when you see this, right, in order to decompose, you will treat this guy as an entity, as one entity, okay? So I would say I will have f of x equals to cubic root of function. And my g is going to be that. As a result, if I compose fg, if I compose f and g this way, I should get exactly this guy. So let's try it, right? So let's test it. So let's test it, right? So when I test it, I will put f composite g. It doesn't matter which one named f, which one named g. You just have to make sure you compose it and you get the function. Why do we need to do this? When you take a derivative of a complicated function, then you need to decompose it layer by layer. It's from outside inside. Remember, when we deal with the composition, what do? We do it from inside out, right? When we decompose, we do it from outside in. Do you see that? When we compose, we do from inside out. When we decompose, we do outside in. Okay, so now we're composing. Okay, so when we decompose, root 3 of x, that's the outside. G is the inside. Do you see that? And once we have written them down like this, you have two simple functions that you can easily take a derivative of. That's the idea, okay? But to test if you get it right, you like to compose it. So you go from inside out, okay? So you have f of g, right? G is 1 plus 4x. And then you apply the function f. So you're gonna get root 3. And this shows to us that we have got the right decomposition. We have got the right decomposition. Did you guys get it? Yes? One more example, and then I will let you guys try it, okay? Number 2. 2 times x raised to the power 3 plus 5 raised to the power 4. We want to decompose it without expanding. Okay? If you're going to expand it, that's going to make it too long, okay? So the way we compose that is from outside in, okay? So what is outside? What is outside, right? I will have f of x equals to, right? I see this as one entity. So my outside function will be x raised to the power 4. Okay, what is my g? G is going to be that guy. You guys see that? So this is from outside in. Are you guys with me? From outside in. Decompose. To test if you got it right, you compose. So just like what we did earlier, you know how to compose, and you can check if you got the right answer. So f of g of x, right? In our case, g is this guy. You don't have to have the parentheses, right? G is this guy, so that's my g. And then my f is the input raised to the fourth power. So that's raised to the fourth power, composed. After we compose it, we should get exactly what was given. You got it? That's decomposition. You wanna try one? Do you guys want to try one? How about you try number 3 and number 4? The consequence of the decomposition, okay, is after the given function is decomposed, it becomes simpler functions. So you can easily find the derivative for them. So that was the idea. That is the idea that will come your way in calculus classes. Okay, would you like to try number 3 and number 4? Number 3 is tangent of pi x. Number 4, okay, is sine of tangent x, or cotangent x, sorry. I did not create these functions by myself. I copied these questions from your calculus textbooks. So decompose, please. You will find it actually it's not that hard, right? Did you get it?
So for the f of x, it would be x, right?
Sorry?
So for f of x, it would just be x, right?
For which one?
F of x.
Number 3 or number 4?
Oh, my bad. I'm talking about number 3.
You said number 3?
Mm-hmm.
No, it's not going to work. F should be tangent x. G of x should be pi x. That's how you decompose it.
I see.
Okay. I'm going to leave the testing part for you, okay? Because if I want to cover some of those special part that I feel near and dear to your success in calculus, and I will have to go a little faster, and you guys will need to come back to watch it and try your hands on it. And so you're gonna test it. I'm gonna leave this part for you, okay? You're gonna test this, okay? And since Farouz is attending the class, and go to his office hours, and he will demonstrate to you, okay? On this next one, you see how you decompose it, right? In calculus, we can find the derivative of a tangent very easily, but not a tangent of pi x. You have to use a chain rule. So that's why you peel it from outside in. Each one has to be a simple function or a basic function. So you can also understand why I coined the word basic function. Each one of the basic functions, of course, there are more basic functions, like x to the power 4. These can also be considered basic functions. But because x to the power 4 can be composed by the function I already listed there. So I didn't list them as a simple function, a basic function. So when I make this, I will just look at tangent a function. Okay, so tangent to me is just tangent omega. So my omega is going to be over here. It's a G. You guys see that? So pi x. So my outside, the function that's from outside is tangent x. Okay, and the inside is pi x. You see that? And for this one, the same thing. The function from outside is sine x, and the inside will be cotangent x. So the next one is going to be f of x. And the g of x is going to be cotangent x. Okay. To wrap up this part, I'm going to pick a question that I have the calculus textbook in front of me. Okay, in front of me. I'm going to pick a question, okay, a complicated one. So you're going to see how you peel them layer by layer. Okay. And this one, this function goes like this. Okay. It says, from your calculus text, okay, from your calculus text. Okay, this is the composed function, which is y equals to cosine root sine tan pi x. Okay, so this will be the last example I'm gonna shock you with. Okay, is that your job here is to decompose it. How do I decompose it? Each function in the process of decomposition is a basic function or a simple function. That's the principle. That's the principle. So the first function, we're going from outside in, right? So it should be cosine x. What is my next function? My next function is going to be square root of x. Right? Because inside of cosine is a square root. That's my square root of x. Inside my square root is going to be a sine x. Right? Because inside the square root is a sine of something. And then inside my sine x, right? Let me call it k of x is what? Is tangent x. What's inside tangent x? The last one, u of x is going to be pi x. So from this process, do you see the peeling process I'm doing here? Layer and layer, layer and inside from outside in. Do you see that? Do you guys see that? Yes? Do you see that? You see cosine as a simple function? Cosine. Okay? Do you see that? And your omega is such. And you see the inside that's a simple function again. And what is that inside? So it's a chain. It's a chain of function composed, right? So that's the sign. And you're going to see this guy as, okay. Whoops. triangle as triangle inside with a sign, right? Right? Yeah, sign. So this is gonna be the heart. So that's my heart. That's the heart. And the heart is tangent pi x. Okay, and tangent will be a simple function. And finally, the spade is pi x. You can see each one of these functions, cosine, root x, sine of something, tangent, pi x. Each one is a simple, each one of them you can find them, or almost you can find them in the basic function table. Do you guys see that? Pi x is a constant, multiply a constant, multiply x. So the derivative is easy to find. Derivative is easy to find. Derivative is easy to find for each one of them. That's decomposition. That's decomposition. You get it? Did you get it?
Mhm.
You think you got the hang of it? You peel it from outside in. When we compose, we're from inside out. Okay? So next, I'm gonna give you about 10 minutes to practice this. Okay, 10 minutes for you guys to practice. Decompose. Okay. Focus on the exercise I give you. Okay. How about you guys try from number 5 to number 10. You know what? Number 1 through number 10, you choose, including the ones that I have done. Okay, you just try your hands on them. I'm going to give you 10 minutes. So we'll finish up, around 9-ish, and then we're going to move on to something else. Okay. So you have number 1. Okay, you may like to try your hands on what we have done already. Number 2. Okay, number 1. Number 2. Number 3. Number 4. Please try. Once you try it, it's no longer hard. Decompose. So you get to see these functions, right? These are the functions you are going to see. That's why some of the students, they came back to tell me the functions in calculus looks weird. They are just the compositions of functions from most of them from the functions we have seen in basic 1 table. Yeah, I never forget that comment. The functions in calculus looks weird. So now you get to see them, some of those weirdo functions. And I hope they will not look weird to you anymore. Try these. Anybody want to go to the breakout rooms? We only have one breakout room, breakout room, not rooms. So how's it going? Decompose.
Professor,
Mm-hmm.
I have a comment, like as you mentioned, the theme of this semester, your class was function, and then you also mentioned, as examples, each trigonometric functions are unique functions. So if we see, for example, sine and cotangent, then we can just remember sine is a one trigonometric function. Therefore, anything after sine would be considered sine x, and then x would be the other function as we have for example number 4. And using the example 1, 2, 3, 4, we can have some idea what to do with the rest of those exercises. For example, question number 8 is a cosine is a function. And therefore, f of x is cosine x, while g of x would be x squared.
Well, yes, number 8 and number 9, they look very much alike, right? But they are very, very different. Cosine x squared, right? The one is being written like this. It's actually cosine parentheses x times x.
Right.
Cosine square x, that's actually is
Function squared.
is cosine x multiply cosine x.
Amazing, yes.
So they are different. Don't think I created these two functions. Both functions, they show up in calculus textbook. Okay, they're from the calculus textbook. So when you decompose them, they actually are different. The result of decomposition will be very different, right? I trust you guys can do number 5, number 6, number 7, all right? Number 8, if you decompose it, right? The outside layer, the outside layer, oops, sorry. The outside layer for number 8 is a cosine x. The inside is x squared. Okay, number 9, however, okay, just you guys try, okay, try to compose them. So to know if you get it right, okay, try F composite G, and you should get cosine x squared. If you try try that. But number 9, however, with this understanding, right, the F is x squared. The G is a cosine x. Right? So you have to, you must understand the mathematical notation. If you don't understand the mathematical notation, you're not going to go very far. Do you guys understand?
Can you show us 5, 6, 7, please?
Number 5. Number 5 is pretty straightforward. Okay, so F would just be e to the power x, and G is just going to be the square root of x. 6, okay, the square root of 2 minus e to the power x. So your F is going to be square root of x. And your G is going to be 2 minus e to the power x. And 7, ln, right? And of course, in this case, F is going to be ln x, and your G is going to be x squared minus 2x. Last but not least, number 10. Okay, this function will show up in your calculus text. Okay, how do we decompose? F of x equals to ln x. G is absolute value of x. So these are the decomposition. And you guys, what you guys need to do is not likely you will be tested this semester. I don't think so, okay? Well, it depends on the instructors, okay? I've taught, but this is something may not be tested on you immediately, but it's going to have a huge impact on your grades next semester. If you understand how to decompose, decompose. So what I suggest for you, I have given you all the answers. So what you need to do is you compose them. What you do, you compose them, okay? You practice with these. You practice with these by composing. As you're getting better at composing, okay, as you're getting better with composing, you will be better at decomposing. Okay, but that's something we don't have a lot of time to do in class. And especially these are the exercise you probably don't find them very much in any other pre-calculus textbook. Okay, and I made them up. Okay, because the many times I taught calculus classes and I saw the difficulties the student had with chain rule. So so that's how in time, when I'm teaching pre-calculus, and I wrote up these exercises. Right? So you guys practice with those. There are so much materials that I will not be able to cover, but I trust that you will be in good hands to practice. Okay. A couple other places I want you guys to practice. I want to give you guys a pointer, right? In terms of your algebraic skill, but I think these algebraic skills, my substitute will be able to help you, like 35A, okay? And there's one section, 35A, 46A, 46B, 45A. If you take a look at those are the exercise I selected from your calculus text, some of them, okay? Some of those are taken from your calculus text, and I took the derivative and then put out the x's and make those exercise that way. So these exact questions may not show up in your calculus textbook. Those are the results after I have taken the derivative, and you need to have the algebraic skill to simplify them. Okay, so just to give you a few, such as basics, 45A, 46A. You know, everyone comes with a B, right? 45A, 45B. These are exercises. It will be super beneficial for you if you could practice them before you enter calculus class. Before you enter calculus class, you will have a little bit advantage. You have a little bit advantage. And the other one is 35A. Okay. There are many such exercises. These are the few that I can get to and point it out to you. So in my notes, there are lots of similar exercises, but these exercises in particular, they are so close, like this close to your calculus class. Okay, in your calculus class, you have to be able to deal with these simplifications. And this is why some of the students came back to me to say the calculus, the algebra in calculus looks weird. Well, that's what you're gonna see. That's what you're gonna see. Okay. But anyway, without further ado, we have covered all of the exercises. So you guys should try these. And if you have any questions, okay, if you have any questions, you should try to mend your algebraic skills, to improve your algebraic skills. So these exercises are the alarms. It tells you must enhance your algebraic skill, which is practice, a lot of practice. Okay, which you're gonna find many in the notes I have sent it to you. Okay, so next, what I like to cover is another very important topics, which is solving inequality and the relationship. Okay, the place I would point it to is number basics. I think in your notes, it might be basic 9A. let me not confuse you too much. It's called basic 9 or basic 10A. In my old version is basic 10A, but I might have changed because I updated my notes every semester. And this semester, I just did not have the new notes printed. Is everybody there?
I'm here.
Okay,
Mhm.
good. So you have lots of exercises to do. This set of exercise, I'm going to work with you. I hope I can finish before my leave. Okay, hold on. That should be. There you go. We're getting closer. Basic. We'll have quadratic. Yeah, I have made so much rearrangement, but that's okay. In the entire section of quadratic, I will try to touch some, but if I don't have time, that's fine, because I have written up documents about those topics, and I also have past recordings addressing those. Okay, so at the end of the class, I will tell you where to, what to study for, right? Those are also very important topics. And I would say in your notes is on basic 9. So I was right. Basic 9, solving inequalities. Okay, so let's get to solving inequalities. Basic 9. Okay, in this section, it's called, I mainly want to share with you the ideas behind it, the ideas behind it. Okay, the ideas. So we're going to have 2 types of inequalities to solve in this part, right? And one is in the case of product, in other cases, in the case of quotient. So today, we'll probably do basic 9, and tomorrow we get to do basic 10, right? So these 2 topics, okay, these 2 topics. Remember when we study mathematical principles, right? When we study mathematical principles, the last 2 principles, principle number 5 and principle number 6 in particular, principle number 6 is addressing positive times positive is positive, positive divided by negative is negative. So those sort of things, right? So how are these principles being used? And these principles are being used here. Okay, right here. Right here. For example, in the case of basic 9, in the case of basic 9, x plus 2 times x minus 3. First of all, we need to understand, okay, we need to understand this is an if statement. This is an if statement. Remember we talked about, right? All the equations in inequality, they're all if statements. Okay, they're all if statement. So what it does say? It says if the product of 2 quantities, okay? It says if is negative, find all possible numbers, all possible values for x. That's a meaning. These are if statement, right? Meaning. And the other one is how do you see these 2 quantities? right? So if the product of x plus 2 and x minus 3 is negative, find all possible values for x. Do you guys follow me? I want you to understand the meaning first, okay? I want you to understand the meaning first. And I also want to show you how the principles are being used. And in the end, we'll show you the function perspective, okay? And I will cover a handful of examples in this area. I hope I will give you some ideas as how to deal with similar questions for different kinds of functions, okay? And mainly, I want to demonstrate to you how mathematical principles apply here. Okay, so first you need to get the perspective correctly. Okay, the perspective, when you read this, right? I remember many years ago, many years ago, right? Long before you were born. You guys are 19, 20, so young, you're younger than my children. Many years ago, when I was your age, or maybe even younger. And I heard the narratives of my teacher, math teacher, right? Because in a lot of my math courses, I would say I took it with much struggle. But one day I heard this teacher was talking about using his words to describe certain equation. And that moment, for some reason, I feel like a light bulb would just light up in my head. I realized I started to understand what he's talking about. So instead of reading open parentheses, x plus 2, close parentheses, open parentheses, x minus 3 is less than 0, you see this as the product of two numbers is negative. Okay, the product of two numbers is negative. Okay, and that of course is the if statement. If the product of two numbers is negative, do you think this time we can relate this to the principle, mathematical principle? What does the mathematical principle say? If the product of two numbers is negative, one of them is positive and one of them is negative. Do you guys agree with me?
Mm-hmm.
Right? You can see how the mathematical principles will now apply. When you read it like I just read, you don't see any connection. But when you see it from a new light, when you see it in the new light, you can see the connection of this inequality as it is related to the mathematical principle. Do you follow me? It is from that light, I always say principle guides steps. It is the principle that guides our steps. If you only memorize the steps and without understanding the principle, we'll always end up confused and puzzled and bewildered. But if we know the principle that's guiding the steps, we can create our own steps. And this is one of those cases. This is one of those cases, okay? As it is in life as well, which I don't want to expand in that direction. Okay, so if the product of two numbers is negative, then we know that one of the two is positive, the other one is negative, right? Well, we can also say if the product of two numbers is negative, then the two numbers must be opposite in sign. So you can have all these different ways to say it. Now you guys understand when I was giving you that exam, midterm exam, I tweaked those questions based on the principles. And I hope you'll go back to take a second look. I'll make the solution midterm exam available, sometimes, maybe I will make them available, okay? And I will let you know because I still have access to Canvas, okay? And I will just not be teaching, so I will let you know when they're available. So those wording are carefully selected so that you can make connections to the mathematical principles. So now with that connection and understanding and the perspective I just addressed, a method is developed. Actually, multiple methods are being developed. Some method there's one method you're gonna see in your calculus text. I'm not gonna use that method. I'm gonna use a even more primitive method. I want to show you how it is so intuitive. It is how it is intuitive, okay? And to add some interesting background about this, and I have been thinking about how to teach solving inequalities like that, okay? Because I found students having a hard time understanding the method taught in the textbook. So one night, a couple of years ago, one night, that's back when before pandemics, one night, well, at my age, sometimes you just wake up, right? In the middle of the night. And I thought of this method. I thought of this method I'm about to show you. And I was so excited. I said, yes, this is the way I'm going to teach my class because this is so much more visual and, illustrative, right? And I was so excited. And of course, the next day I was teaching that way. But just out of curiosity, I wonder, am I the first person who thought of that, right? Sometimes that thought gets you even more excited, right? So I went through a lot of reference books. And sure enough, I was not the first person thought of that. I was not, okay? The way I'm about to teach you, even though I thought of it, it wasn't my invention. Someone much older than I, who wrote a textbook about this, he also used the same method. Of course, I was just as excited, right? And but this is in a very, very old textbook. The textbook, if you look at the textbook, I don't think I can get it from my bookshelf, but it was a very old textbook, probably your great grandfather used or something like that. I just found them in the library, in the department. But anyway, without further ado, so the method I taught, I'm going to show you is here. Are you ready? Are you ready? This is one of the methods. This is one of the methods, okay? So the thinking process goes, first of all, you look at this expression, right? You look at this expression on the left-hand side. It's a product, right? So what I will see, I see the first one as A. I see this as A times B is negative. My A is X plus 2, my B is X minus 2. So the idea is to analyze when is A positive and when is B positive, negative in the different cases. Do you guys follow me? Okay, so the idea, so I'm going to give you some heads up about the idea, okay? The idea and the analysis is we want to say if the product is negative, right? We wish to analyze when A is positive negative 0. And when B is positive negative 0. Do you guys follow me? And then we put them together. So that's the idea. So here comes because A is x plus 2, B is x minus 3. So we know that x plus 2 as a quantity, we don't know the value of x for sure. We don't know the value of x, but we know that x can be any real number, don't we? Right? So further analysis, we know that x plus 2 can be any real number. Okay? X can be any real number. And in particular, I know that x plus 2 is 0 when x is negative 2, yes? You guys follow me? Yeah? Do you agree? Do you agree? Yes? Right? When you substitute x by negative 2, negative 2 plus positive 2 is 0, right? And what is more, so if you look at the number line, right? If you look at the number line, then you can see x plus 2 is 0 when x is negative 2. If you see x plus 2 as a function, right? If you see x plus 2 as a function, you know when the output is 0, right? When the output is 0. And you also will know that when x plus 2 is negative and when x plus is positive, yes? What is more, so we also have discovered if x is less than negative 2, x plus 2 is negative. When x is greater than negative 2, x plus 2 is positive. Do you agree? So the entire number line is covered. Do you follow me? How do I know that? You pick any number less than negative 2. You plug in, right? Suppose I pick x equals to negative 3. If x equals negative 3 plus 2 is negative, right? Negative 3 plus 2 is negative, right? You follow me? You guys follow me? You're not used to think this way, right? You're not used to think this way. But that's why I want to present this way. This is called critical thinking, okay? Critical thinking. When x is larger than negative 2, when x is larger than negative 2, say I pick x equals 0. 0 is larger than negative 2. And 0 plus 2 is larger than 0. Do you agree with me? And is this true for any? This is just examples. This is not proof, right? If you pick any number less than negative 2, will x plus 2 be negative? Pick any number that x is larger than negative 2, will x plus 2 be positive? So in your mind, you run through negative 3, negative 2.5, negative 2.6, negative 10, negative 20. You plug in any one of them that is less than negative 2. X plus 2 is surely negative. You follow me? Similarly, for x is larger than -2, if you pick any number larger than -2, what are the numbers larger than -2? -1.9, -1.5, -1, 0, 1, 2, 3, 4, 1.5, 6.7. You have many numbers. Any one of them you plug in, x plus 2 will surely be positive. Do you follow me? This is the analysis about the sign of x plus 2. So what I would conclude, okay, what I would conclude is that if I have a number line, okay, this is my number line at a -2, -2, -2. The sign of x plus 2. What is the sign of x plus 2? The sign of x plus 2 at -2, right? When x is equal to -2, x plus 2 is what? X plus 2 is 0. Right? 0 is a neutral number. It's neither positive nor negative. But for x is less than -2, what will be the sign of x plus 2? They will be negative. For number larger than -2, right? For x larger than -2, the sign of x plus 2 will be positive. All positive. No matter what number you have chosen. Do you agree? So this analysis turned into this picture. This picture demonstrates the sign of x plus 2. Do you follow me? Does everybody follow me?
Yes.
Yes.
Anybody has any questions? Yes, we're going slowly because I want you to understand this method as it's related to the mathematical principle. Okay? For the same method, we can analyze the sign of x minus 3. Okay? So for x minus 3, we have similar analysis as well. When is x minus 3 0? Could you tell me, when is x minus 3 0? When is x minus 3 0? Answer? Well, x equals 3, right? Right? You just said x minus 3 equals 0 and adding 3 on both sides, yeah, right? Set x minus 3 equals 0. Then x equals to 3, right? Okay. So when x is larger than 3, x minus 3 is positive. When x is less than 3, x minus 3 is a negative. Right? All you have to do is subtract 3 on both sides if you just pure technique to consider technically. So we will have a similar picture about the sign of x minus 3. So I will have a number line, and this number line at 3, right? At 3, x minus 3 is 0. Neutral sign. When x is less than 3, they're negative. Hold on. They're negative. If x is larger than 3, they're all positive. So you can see the distribution of a negative sign, positive sign now is set. You follow me? So we're analyzing the sign distribution. So if I put this on the solution part, right? I've spent so much time explaining to you. I hope this is beneficial to you. So on my solution, I would just focusing on the sign of these two quantities. Okay. Since we want the product to be negative, right? So let's consider the sign of the product. The sign of this product, right? If you consider these as two number lines, there's one number line here, one number line there. And now I'm building a third number line. And these number line, there's a -2 here, right? There's a +3 there. So if you look at this as a giant, no, you look at these as a 3 number line, okay? And then I'm gonna just draw this line here, add a -2 to the left of -2. If I pick any number here, suppose I pick a number, right? Less than -2. And this number plug in x plus 2, I'm gonna get a negative number. This number plug in x minus 3, I'm gonna get a negative number. Negative times negative, what do I get? Negative times negative is positive. Do you guys follow me? Do you follow me? Yes? So when the number I pick is less than -2, I encounter negative times negative. So that's going to give me positive. So the product is a positive. Do you follow me? At -2, what happens if I pick number -2? If I pick -2, x plus 2 will be 0. 0 times anything will be 0. If I pick a number between -2 and 3, if I pick a number between -2 and 3, I pick a number from here, just any number, then this number will make x plus 2 positive, x minus 3 negative. Positive times negative is going to be, what is a positive times negative? It's going to be negative, right? Do you follow me? Positive times negative is negative, right? Mathematical principle. At 3, what happens? At 3, what happens? When x is equal to 3, x minus 3 is 0. 0 times anything is 0. So this is 0. Right? 0 times 2 is 0, right? Now, when I pick a number that is larger than 3, what happens? Larger than 3. And I take this number, I plug in here, and I take that number, I plug in here, what do I get? I get a positive times positive. Positive times positive is positive. Yes? So this is the method I was excited in the middle of the night. I don't know for what reason. You might be bewildered why I would be excited for something like this, because I hope that if I explain well, I can help you to thoroughly understand this method as it is related to the mathematical principle. Do you guys follow me? And now the solution is already here. Because we want if the product is negative. So what number will make the product negative? The numbers between -2 and 3. At -2, it's going to make it equal to 0. At a +3, it's going to make it equal to 0. So all the other numbers are not a solution. So our solutions are here. Solution to this inequality, the if statement, are between -2 and +3 exclusive. Did I explain this method so you understand? Yes or no?
Mm-hmm.
Once you because what I hope is once you understand one, you're going to understand many. That's my goal. Okay. And from this example, it also explained to you and to me as well, why factoring is so important. As I mentioned before, right? If you look at the 6 mathematical principles, at least 2 of them are related to factorings. Take a second look at the mathematical principles. Number 6, related to principles, related to factoring. Number 5, related to factoring. If you want to say it, number 4 also related to factoring, but not that directly, but it's also, so at least 2 of them are related to factoring. That explains why we cover factoring in intermediate algebra and elementary algebra. And you continue to factor throughout college algebra, trigonometry. And so you should not be surprised. Factoring as a technique will also be required for your calculus classes. And the fundamental reason is principle number 5 and principle number 6. That is the reason why factoring is so important. You got it? Yeah? Okay, we have reached the end of the class. Actually, I have passed, okay? But I still haven't covered all. I want to talk about these ideas of solving these inequalities. And I will be teaching the next class at 11:15, and that class is 2 hours long. So I might be able to cover more than this one I covered here today with you guys. So I will make that recording available to you as well, maybe at the end of the day or the beginning of tomorrow. Because today I will have I have to go to I'm going to visit the hospital this afternoon. So if I cannot post it tonight, I will post it tomorrow. So hopefully I will give you these ideas as they are related to mathematical principles. And if you have any question, don't hesitate to reach out to me. I'm a little less available in the afternoon because I'm gonna have to driving to Pasadena. So I won't be back until much later tonight, but I will try to make them available, the recording from the other class, which I believe I will cover more on these topics. Once again, I'm shooting for better understanding for you. So in the end, you find mathematics actually is simpler than you thought. Okay, so without further ado, I'm going to let you go, and I'll see you guys tomorrow.
Professor, I write in the chat my weekly hours in Math Study Center. If students want to freshen up with their algebra skills and everything else you're teaching us, they can find me over there.
Okay, thank you so much, Farouz. I see it.
You're
Appreciate it.
welcome. Thank you.
Thank you, guys. I'll see you guys tomorrow.
Bye.
Thank you,
see you tomorrow.
Professor. Thank you, Farouz.
Thank you, guys. Have a great day.